The stars above, what secrets do they keep? One of our biggest questions has always been, are we alone? We've now discovered thousands of planets beyond our solar system. But how many of those distant worlds have the conditions for life as we know it? How many have water vapor, a beacon indicating that oceans might be present? How many have gases like oxygen and methane, possible signs of life itself? And of those which might truly have life? After decades of asking, these space technologies could finally bring us the answers. Getting across the solar system with today's rockets is a bit like flooring a car, turning the engine off and hoping momentum carries you where you want to go. This concept flips that idea around by favoring patience over brute force, applying a gentle push for a very long time instead of one dramatic blast. The system lives in space rather than launching from Earth. It would wait in low Earth orbit until another spacecraft arrives, then attach and act like a tugboat in deep space. Once connected, it begins a slow but continuous acceleration, building speed day after day. It's not flashy, but over weeks that constant push can move spacecraft toward the Moon, Mars, or even the outer planets. Only after some time does the scale of the system really sink in. The engine can produce thrust in the range of a few to a couple dozen pounds force, which sounds small, but it runs continuously. That efficiency shows up in its specific impulse, estimated between 10,000 and 15,000 seconds, far beyond chemical rockets. Exhaust speeds reach hundreds of thousands of feet per second, and electrical output can reach up to 2 megawatts. Coming back from space normally means fire, noise, and a long recovery at sea. VORTEX imagines a calmer ending, more like rolling to a stop on a runway than splashing down in the ocean. It is a concept for a reusable spaceplane that flies to orbit and then returns to Earth the way an aircraft does, closing the mission as a single journey instead of a one-way trip. The idea comes from Dassault Aviation, a company better known for airplanes than rockets. VORTEX is treated as a flying vehicle from start to finish, expected to handle both spaceflight and atmospheric flight. Once in orbit, it behaves like a spacecraft. Inside the vehicle is an internal bay that can carry equipment or objects meant to be retrieved from orbit. Keeping payloads inside allows them to be shielded during launch and re-entry, and supports missions where items need to come back intact. Development is planned in stages. The first vehicle is a smaller demonstrator used to study hypersonic behavior and landing dynamics. Later versions increase in size, moving toward longer orbital operations and more complex missions. Space is starting to look a little less like a place where you pack everything once and hope for the best, and a little more like a long road trip where you know there will be stops along the way. That idea sits behind a growing shift in how space missions are planned and supported. Instead of treating every launch as a standalone event, the focus moves to building a connected system in orbit. Spacecraft would be able to meet each other, line up on their own, and link together without someone on the ground steering every move. Once connected, they could pass fuel between them, or be moved to new orbits by specialized vehicles that act like tow trucks in space. This changes what happens after launch. Rather than flying with a fixed amount of fuel and a countdown on their usefulness, satellites and other spacecraft could stop, refill, and continue operating. That makes longer missions more practical and reduces the pressure to replace equipment just because it has run low on propellant. The European Space Agency describes this future as one with orbital hubs that function a bit like transportation terminals. These hubs would support refilling, basic servicing, and preparation for missions heading farther from Earth. To make that work, a lot of attention goes into automation, so spacecraft can approach safely. One clear example of how this could work is an uncrewed fuel depot in orbit. Supply rockets would bring fuel to it, and visiting spacecraft could take what they need before moving on. This could support trips toward the Moon or Mars. If FedEx ever looked up and felt nervous, this would probably be why. Imagine a small spacecraft quietly circling Earth, not carrying people, not taking photos, just waiting. It's there in case something on the ground suddenly needs to arrive fast. Really fast. Instead of days or weeks, think minutes. That's the basic idea behind this system. Up in orbit, the vehicle stays on standby, with cargo already on board. Nothing dramatic happens until a command is sent. When that signal arrives, it uses its own engine to slow down and drop out of orbit. From that point on, computers inside the craft take control. They guide it through the atmosphere, adjusting its position and angle as it descends. Its shape lets it generate lift, so it can steer during the fall instead of dropping straight down like a rock. As it slows near the ground, parachutes deploy to finish the landing. Only later do the numbers start to matter. The vehicle stands around 8 feet tall and about 4 feet across, making it compact by spacecraft standards. Even so, it can carry close to 500 pounds of cargo. After recovery, it isn't thrown away. The plan is to check it, refurbish it, and send it back up again. This project comes from Inversion Space, with technical work connected to research from NASA. The focus isn't tourism or science experiments, but fast delivery and emergency response. Think of this as a very large rocket system meant to fly again and again instead of being used once and thrown away. It has two main parts stacked on top of each other. The bottom part is called Super Heavy, and its job is to lift everything off the ground. It runs on liquid oxygen and liquid methane, and uses 33 powerful Raptor engines working together. Once its job is done, it heads back toward the launch area instead of falling into the ocean. On top of it sits the Starship spacecraft, which is also powered by methane and oxygen, and carries both fuel and cargo. The full rocket is close to 400 feet tall and about 30 feet wide. Starship itself holds a massive amount of propellant, measured in millions of pounds, which is needed for long-distance travel. When operating in Earth orbit, it is expected to carry more than 220,000 pounds of payload once refueling in space becomes routine. To deal with heat of coming back through an atmosphere, the ship uses ceramic heat shield tiles on one side, which take the brunt of the heating during re-entry. The idea behind this system, as described by SpaceX, is to treat Mars travel more like a repeating operation than a single historic event. Instead of sending one spacecraft every few decades, the goal is to send many, carrying supplies first and people later. Early missions planned for the mid-2020s are meant to fly without crews, so engineers can study what happens during the trip and during landing. Landing on Mars is also difficult because the atmosphere is thin. The ship is expected to slow down using its shape and heat shield, and then fire its engines close to the surface. Over time, there are also plans to make fuel on Mars using local resources, which would allow future ships to return without bringing all their fuel from Earth. Inside this space station, there is about 1,590 cubic feet where astronauts can live and work. The whole structure weighs close to 32,000 pounds and stands around 33 feet tall. Solar panels supply about 13,200 watts of power, which runs life support systems and research equipment. Up to 4 people can stay on board at a time for short missions. One of the most striking features is a large domed window, about 3.6 feet wide, giving clear views of Earth below. The station is being developed by Vast Space, a US-based company founded in 2021. Its main focus is in creating commercial space stations as the International Space Station moves closer to retirement. The idea is to help keep people working and researching in low Earth orbit without relying only on government programs. The first station, called Haven 1, is planned to launch no earlier than May 2026 on a Falcon 9 rocket from SpaceX. Astronauts would travel to and from the station using Crew Dragon spacecraft. Haven 1 is not meant for permanent crews, but for short visits that focus on research, testing new technology, and private missions. This spacecraft is about 30 feet long, and its wings stay folded during launch before opening once it reaches space. When it flies with its cargo module, the total launch weight falls between roughly 20,000 and 24,000 pounds. Launch happens vertically on a Vulcan Centaur rocket, packed inside a 16-foot fairing with the wings folded. What makes this vehicle different is its shape. Rather than relying on large wings or dropping straight down like a capsule, its body naturally creates lift as it moves through the atmosphere. That allows it to come back through the air in a more controlled way. As it descends, it shifts into a glide and lines up for a runway landing. The idea behind this spacecraft goes back to older NASA studies that looked at space vehicles landing like aircraft. Early plans included carrying astronauts, but over time the focus moved toward cargo missions. The main vehicle is meant to fly again and again. Most of the cargo travels in a separate module attached to the back. This section holds pressurized supplies, external payloads, and the solar panels that provide power. It can stay in orbit for several weeks while supporting operations. Before the spacecraft heads home, the module separates and burns up safely in the atmosphere. Right now, its main job is supporting space station supply missions. One of its strongest points is the ability to bring experiments and hardware back intact. Only a few spacecraft can do that. The idea starts with how the structure is made. A large 3D printer, about 20 feet across, spreads layers of prepared lunar soil to form solid parts. It can build upward at about 6 feet per hour, and future versions aim to work faster. During testing, the system produced a single block weighing close to 3,300 pounds. The material itself is not raw moon dust. It's a mix of simulated lunar soil, magnesium oxide, and a liquid salt binder. When the liquid is applied, it triggers a chemical reaction that turns the mixture into something similar to stone, without needing extreme heat. The shape of the habitat is a dome that naturally carries weight through compression. Inside this printed shell sits an inflatable living module. The inflatable part is where people would actually live, since it can hold air and pressure. The printed shell around it acts like a protective cover. It does not need to be airtight, which simplifies the structure and lets the material focus on strength and shielding. Protection is a major concern on the Moon. The printed walls help block radiation and protect against small meteor impacts. Tests were done to see how well printed regolith handles radiation, and the results were used to guide the design. Another challenge is printing in a vacuum, where liquids can evaporate quickly. Because real lunar soil cannot be collected in large amounts, testing relied on volcanic rock from central Italy that closely matches moon soil. Alongside the binder method, researchers also explored using concentrated sunlight to fuse soil directly. If rockets had personalities, this one would be the calm, capable friend who doesn't talk much but always shows up ready. It isn't flashy for the sake of it. It's more about doing the job cleanly and coming back in one piece. This launch vehicle marks a bigger step for Rocket Lab as it moves beyond small rockets into a size that can make more complex missions. It fits into a middle space in today's launch market, sitting between small satellite launchers and the largest rockets in service. That middle ground matters more than it sounds, because many modern missions don't need extreme lift capacity, just something reliable that can carry multiple large satellites at once. The rocket uses a familiar two-stage setup. After liftoff, the first stage does the heavy work of pushing through the atmosphere, and then separates so the second stage can finish the trip to orbit. What sets it apart is how much of it comes back. The first stage returns after launch, and even the payload fairing stays attached instead of being dropped into the ocean. It opens briefly to let the upper stage go, then closes again before heading back down. Fuel choice plays a big role here. Liquid methane and liquid oxygen power the engines. Methane burns cleaner than older fuels, which helps keep the engines in better shape after flight and reduces cleanup time between launches. If sending a package back from space were as easy as returning an online order, this capsule is trying to make it feel closer to that idea. Instead of focusing on giant satellites, it deals with a much simpler question. How do you get valuable items back from orbit without turning the return trip into a complex mission of its own? The spacecraft is a small, uncrewed capsule meant to carry research samples and manufactured materials into low Earth orbit, and then bring them back to Earth. It is meant for missions where the cargo matters more than the vehicle itself. Experiments can be monitored during flight, and the capsule keeps its internal conditions controlled, so sensitive payloads are not exposed to extreme changes. What really stands out is the way it comes home. Rather than relying on a solid heat shield and parachutes, it uses a large inflatable structure that deploys before re-entry. This expanded shape creates drag high in the atmosphere, slowing the capsule down early and reducing heating loads. The materials release heat outward instead of burning away, which allows the system to remain relatively simple while still handling the stress of re-entry from orbit. Once in orbit, the capsule can stay there for months if needed. It can carry roughly 220 pounds of cargo. The first orbital test flight took place in April 2025 on a Falcon 9 rideshare launch. The capsule completed one full orbit, deployed its inflatable heat shield, and transmitted system and payload data. Think of New Glenn like a skyscraper that learned how to fly, take a break in space, and then calmly come back home. This launch vehicle is Blue Origin's move from short space hops to full orbital work. After years of testing smaller systems, this is the rocket meant for serious jobs. Its size allows it to carry large satellites or several payloads at once, which opens the door to more complex missions. The way it flies is split into two main parts. The first stage handles the hard work of leaving Earth, using 7 BE-4 engines that burn liquid oxygen and liquid methane. Once that stage separates, the second stage takes over. It uses liquid hydrogen and liquid oxygen, a combination that works especially well in space. Later in the flight, something interesting happens. The booster doesn't get thrown away. Instead, it slows itself down by restarting its engines, guides itself back through the atmosphere, and lands upright on an ocean platform named Jacqueline. That landing process worked as planned during the second mission in 2025, showing that recovery isn't just theoretical. Watching a rocket gently come back down and land near where it started feels a bit like seeing someone toss a pencil into the air and have it land perfectly upright on a desk. It looks simple for a moment, until you remember how many things have to go right for that to happen. That sense of controlled precision is what this test flight was really about. The vehicle itself is not the towering kind of rocket most people picture. It's closer in size to a tall utility pole than a skyscraper, and it was never meant to head into space. Instead, it was used to practice the basics, going straight up, staying under control, and coming back down in one piece. The flight lasted less than a minute, but during that short time, the rocket climbed, slowed, turned around, and guided itself back to the ground with surprising accuracy. The rocket stands at around 20 feet tall and measures just under 3 feet across. It weighs roughly 2,000 pounds when empty and close to 3,000 pounds when filled with propellant. During the test, it reached an altitude of about 890 feet before descending and touching down within roughly 14 inches of its target point. Trying to land on the moon is a bit like tossing a glass onto a coffee table from another city and hoping it lands upright. There's no room for errors, and everything has to work perfect. This robotic lander exists for one clear purpose: bringing scientific tools from Earth to the moon, placing them carefully on the surface, and supporting their work for a limited time. It doesn't stay active for years. Instead, it acts more like a careful courier, arriving at a precise spot, setting things down, and staying active while sunlight allows. The spacecraft is developed and operated by Firefly Aerospace under NASA's Commercial Lunar Payload Services, which relies on private companies to carry research instruments to the moon in support of the broader Artemis program. During its journey and landing, the lander manages many tasks at once. Solar panels unfold on the surface to provide electrical power, while internal batteries support systems during travel and descent. The first mission touched down on March 2025, near Mare Crisium on the moon's near side. It delivered 10 NASA experiments studying lunar soil, underground heat, solar wind effects, and laser ranging. The lander sent back images and data for roughly 2 weeks before lunar night limited power. The journey began aboard a SpaceX Falcon 9 rocket and took about 6 to 8 weeks, with more missions planned for other regions of the moon. Imagine trying to walk up to a spinning shopping cart in a dark parking lot without touching it. Now imagine doing that in space. That's the basic challenge behind this mission. It isn't dramatic, but it deals with one of the messier realities of modern spaceflight: large objects that were never meant to be visited again. The spacecraft spends its time circling Earth, quietly keeping pace with an old rocket stage that's been drifting since 2009. Instead of grabbing anything, it watches. Cameras, infrared imaging, and laser-based distant sensors help it figure out how the object moves, how it's oriented, and what shape it's really in. By slowly closing the distance and stopping at planned points, the spacecraft can look from different angles and under different lighting conditions. It also practices pulling away safely, which matters a lot when the thing you're studying can't respond. The target is a retired HIIA upper stage, a large piece of hardware left over from a previous launch. It's long, wide, and heavy, and it doesn't have working systems anymore. It doesn't send signals, doesn't hold a fixed orientation, and doesn't care if something approaches it. That unpredictability is exactly why it's useful to study. Watching how it spins, what parts stick out, and how its surface looks up close helps reduce unknowns for future cleanup efforts. The mission, called ADRAS-J, and it is launched in early 2024 on a Rocket Lab Electron rocket, and now operates a few hundred miles above Earth in low Earth orbit. The spacecraft itself weighs a few hundred pounds and has shown it can approach within tens of feet while taking images every half minute. This spacecraft would orbit Mars and focus on one main job: moving data back and forth between Mars and Earth. It carries a propulsion system that uses solar electric thrusters for long trips through space and chemical engines for stronger maneuvers near Mars. It can deliver more than 2,200 pounds of payload into Mars orbit. On board are several communication systems, including steerable high-rate antennas, a wide beam system that covers large areas around Mars, and smaller UHF relay units that help talk to landers and rovers on the surface. Mars exploration depends heavily on communication, even though it often goes unnoticed. Every image sent back relies on orbiting spacecraft acting as messengers. Many of the orbiters currently doing this work have been operating for a long time, and some are expected to stop working in the coming years. This is where the Mars Telecommunications orbiter idea comes in. Introduced in 2025 by Blue Origin, the concept focuses entirely on keeping communication links strong, rather than carrying science instruments. Instead of supporting one mission at a time, it would handle data for multiple spacecraft, both old and new. This observatory works by collecting light across ultraviolet, visible, and infrared wavelengths, which lets scientists see many different details in space that would otherwise be missed. Its large mirror, expected to be between 20 and 26 feet across, gathers far more light than older space telescopes. It will operate far from Earth, about 930,000 miles away, in a quiet region of space where temperature changes are small and long observations are possible. The main focus is on finding and studying planets around other stars, especially ones similar in size to Earth. Instead of guessing a planet is there by watching how a star moves, this telescope aims to actually see the planet itself. Scientists plan to look closely at least 25 planets that sit in the so-called habitable zone of their stars, where temperatures might allow liquid water on the surface. These stars are relatively close by in cosmic terms, within about 80 light-years of Earth. Once a planet is visible, scientists study its atmosphere by looking at how light changes as it passes through or reflects off it. Certain gases leave clear fingerprints in the light, including oxygen, methane, and water vapor. By measuring these patterns, researchers can learn what a planet's atmosphere is made of. The telescope is not limited to planet hunting. It can also be used to study how galaxies form, how stars are born, and how different elements spread through space over time. It can even observe objects in our own solar system, using the same tools applied to distant worlds. Imagine taking a road trip where, instead of missing an exit, you accidentally drive higher than anyone has in decades. That is roughly the spirit of this mission. It was not about getting somewhere specific, but about seeing how far current space technology could be pushed and what people could learn along the way. This flight happened in September 2024 and was funded privately, with SpaceX running the mission. Rather than heading to a space station, the crew aimed much higher than typical modern missions. After reaching orbit, they gradually raised their path around Earth until they were far above the altitude where astronauts usually operate today. That higher route exposed both the spacecraft and the crew to stronger radiation and tougher conditions, which was exactly the point. After collecting data in that environment, they lowered their orbit and spent the rest of the trip carrying out planned work. The spacecraft itself was roomy enough for 4 people to live and work together for several days. It used small thrusters to carefully adjust its position in space and carried a separate escape system that could quickly pull it away from the rocket during launch if needed. The rocket that lifted it off relied on 9 engines firing together, producing an enormous amount of force to leave Earth behind. One of the most talked about moments was a spacewalk done in a very different way than usual. Since the capsule does not have a separate airlock, the entire cabin was depressurized. All 4 crew members stayed in their suits, while 2 of them took turns positioning them at the open hatch. The goal was to see how well the new suits worked and how practical this approach might be for future missions. This spacecraft is a large vehicle, about 26 feet tall and a little over 14 feet wide. When it launches, it weighs around 35,000 pounds. It can carry a mix of supplies, with close to 8,000 pounds stored inside a pressurized section that astronauts can access directly, and about 3,860 pounds mounted outside for hardware meant to operate in space. It flies in low Earth orbit, roughly 186 to 311 miles above Earth, following the same path as the space station. Once it arrives, it can stay attached for up to 6 months, and even after leaving, it can keep flying for more than a year to support additional experiments. Power comes from a large solar array mounted on the service module, angled to work well as lighting conditions change during each orbit. This vehicle is part of Japan's current approach to moving supplies to space. It was developed by Japan Aerospace Exploration Agency as the next step after its earlier cargo ships. The idea was to keep what already worked well, while giving the spacecraft more room to take on new tasks. Most of the time, its job is to deliver food, equipment, experiments, and spare parts to the International Space Station. When it reaches the station, it does not dock by itself. Instead, it slowly approaches and waits while the station's robotic arm grabs it and guides it into place. After that, astronauts can open it from inside the station and start unloading. Items mounted on the outside are removed separately using robotic systems. If you've ever looked out an airplane window and thought, "This is nice, but I wish I could see a little more," this experience feels like the long, patient answer to that thought. Instead of rushing anywhere, everything here moves slowly and on purpose, giving you time to settle in before you even start thinking about how far up you're going. Inside, the capsule feels more like a quiet lounge than a piece of aerospace hardware. The space is open enough to move around comfortably, with seating arranged in small pairs so conversations feel natural. Large windows take over most of the walls, pulling your attention outward no matter where you sit. The materials are chosen for extreme conditions outside, but on the inside, the atmosphere stays familiar, similar to what you'd experience on a regular airline flight. The ascent doesn't feel dramatic. The capsule rises gently beneath a hydrogen-filled balloon, climbing at a pace that feels more like an elevator than a launch. It takes about an hour and a half to reach its cruising height, where nearly Earth's entire atmosphere sits below you. Outside, temperatures plunge and the air thins to almost nothing. But inside the cabin, those changes never intrude. The pressurized shell keeps everything quiet and stable, so your body never has to adjust to harsh shifts. Imagine a spacecraft that goes to space, stays there for a while doing its job, and then comes back with everything still inside. That's basically what this system does. It's made of two parts working together. One part stays in orbit. The other part is the section that actually returns to Earth with the experiments and equipment. Inside, there's room for a fairly large set of experiments. The cargo area can hold a little over 1,300 pounds and offers about 42 cubic feet of space. The main door is wide enough to load complex hardware, and there are smaller side doors that let teams access sensitive items close to launch or quickly after landing. While in orbit, the spacecraft provides very low gravity conditions. In some orientations, the remaining acceleration is extremely small, which matters a lot for experiments involving fluids, biological samples, or materials that behave differently without gravity. Some payloads stay enclosed, while others can look out through the cargo bay opening to observe space or Earth. When the mission wraps up, the returning module slows from orbital speed, re-enters the atmosphere, and deploys a large steerable parafoil at around 16,400 feet. That parafoil guides it to a runway landing. The whole system is developed by the European Space Agency and is meant to make trips to orbit and back feel more routine. Next one is a compact spaceplane, about 29 feet long, with a wingspan close to 15 feet and a height of roughly 9 feet. In orbit, it moves using a propulsion system that relies on chemical fuels commonly used in spacecraft. Power comes from solar panels that unfold in space, with batteries backing them up. It spends most of its time in low Earth orbit, though some missions take it on higher, more stretched out paths. When it comes back, it hits the atmosphere at speeds close to Mach 25 and lands on a runway without any pilot on board. When people see it on the ground, it often reminds them of a small space shuttle, but it isn't meant to carry astronauts. This vehicle was developed by Boeing for the US Space Force. Its job is to stay in orbit for long periods, test new technologies, and then bring those items back so engineers can study how they handled the space environment. The project started back in 1999 with NASA, before moving through DARPA and eventually into military use. The first mission flew in 2010, and since then, 2 vehicles have been reused over several missions. Together, they've spent thousands of days in orbit and traveled more than 1 billion miles. Think of this spacecraft as a small, self-contained place where 4 astronauts can live and work while traveling far from Earth. Inside, there is about 316 cubic feet of space, which is more room than earlier capsules like Apollo. It can support a crew for roughly 3 weeks without connecting to anything else. The part where the astronauts spend their time is called the crew module. It is the only section that comes back to Earth. Its shape helps it stay stable during re-entry. Inside, systems quietly handle air, temperature, and carbon dioxide levels so the crew can breathe normally. There is also equipment for drinking water, eating, and using the toilet. Most of the flying is done by computers, but astronauts can take control through digital screens if they need to. Attached underneath is the service module, built with help from the European Space Agency. This section carries fuel, water, oxygen, and other supplies the crew depends on. It also holds the main engine and smaller thrusters that guide the spacecraft through space. 4 large solar panels unfold after launch and provide electricity for everything on board, from navigation to communication with Earth. On top of the capsule during launch is an escape system. It stays there only during liftoff. If something goes wrong early on, it can pull the crew module away from the rocket very quickly. Once the spacecraft reaches space, that system is no longer needed and is released. This spacecraft is operated by NASA and has already completed unscrewed flights that tested how it performs far from Earth. Imagine a flight that doesn't launch straight up like a traditional rocket, but instead starts the way an airplane does. A large carrier aircraft takes off from a runway, climbs to high altitude, and then releases a smaller spacecraft underneath it. Once released, the spacecraft fires its rocket motor and heads upward toward the edge of space. The whole journey, from release to landing, takes about 10 to 15 minutes, with a few quiet minutes where everything inside floats. The spacecraft carries 2 pilots and up to 4 passengers. During the climb, everyone feels strong acceleration, followed by weightlessness as the vehicle reaches its highest point. For a short time, passengers can unstrap, float around the cabin, and look out through wide windows to see Earth's curve against the blackness of space. After that moment, the spacecraft turns back toward Earth. It uses a special re-entry configuration that helps keep it stable as it descends through the atmosphere. There's no engine firing on the way down. Instead, the vehicle glides like an aircraft and lands on a runway, much like a plane returning from a test flight. This system is operated by Virgin Galactic, which runs flights out of Spaceport America. Along with carrying passengers, the spacecraft can also take research equipment. Experiments are placed in lockers about the size of a small suitcase, each able to hold up to 50 pounds and draw electrical power during flight. Blue Origin has been flying a suborbital rocket system that's meant to go up to space and come back down again, over and over. The whole setup is automatic, so there are no pilots on board. Each flight lasts about 11 minutes and takes passengers past the edge of space, around 62 miles up, where they get a few minutes of weightlessness before returning to Earth. The system has 2 main parts. One is the booster, which lifts everything off the ground and later lands back at the launch site. The other is the capsule, which carries people or research payloads. At liftoff, the booster's BE-3PM engine produces around 110,000 pounds of thrust, using liquid hydrogen and liquid oxygen. When it burns, the main exhaust is water vapor. After the engine shuts off, the capsule separates and keeps rising for a short time while the booster starts heading back down. On the way back, the booster controls itself using a mix of fins and drag brakes. These help manage speed and direction as it moves from thin air into thicker atmosphere. The engine restarts during descent, slowing the booster until it touches down vertically at roughly 6 miles per hour. Earlier flights showed even lower landing speeds, closer to 4 miles per hour. Landing legs deploy near the ground so the booster can set down upright. This rover is a very large vehicle, about 19 feet long, 17 feet wide, and 12 feet tall. It normally carries 2 astronauts, but it can hold up to 4 if needed. The idea is that the crew can stay inside it for 30 to 45 days without needing to return to a base. Unlike earlier moon vehicles, this one lets astronauts take off their spacesuits while inside, which makes daily tasks far less tiring. Inside the cabin, everything needed for daily life is packed into a compact layout. There are systems that manage air, pressure, temperature, food, water, and waste, all working together, so the crew can live and work comfortably for weeks at a time. Getting around the moon is handled by 6 wheels that are all driven independently. This helps the rover keep traction on loose lunar soil and deal with slopes and scattered rocks. The wheels use solid metal tires instead of rubber, since lunar dust quickly damages materials used on Earth. Navigation works without GPS. The rover relies on cameras, sensors, and onboard computers to understand where it is and what lies ahead. These systems constantly check the surroundings, helping the rover avoid hazards and plan safe paths during travel. Power comes from a combination of solar energy and hydrogen fuel cells. During the long lunar day, sunlight is used to split water into hydrogen and oxygen. Those gases are stored and later turned back into electricity during the long lunar night. This mission is basically about bringing real pieces of Mars back to Earth and doing it carefully. The samples are kept in small titanium tubes that weigh less than 2 ounces and are less than 6 inches long. They're painted white so they don't heat up too much in the sun. Each tube has markings etched into it, which helps scientists know exactly where every piece came from and what it contains, even years later. Right now, those samples are being collected by the Perseverance rover in Jezero Crater. Perseverance drills into rocks and soil, seals what it collects inside the tubes, and stores them on the Martian surface. The idea is to keep everything as close as possible to how it was found. Nothing fancy, just careful handling, so the material stays useful for study once it gets home. The return process is complicated because Mars is far away, and there's no simple way to bring things back. A future mission will land near Perseverance and pick up the tubes. They'll be loaded into a small rocket called the Mars Ascent Vehicle, which launches the samples into orbit around Mars. Once the samples are in orbit, an Earth return orbiter moves in to capture them. This spacecraft is huge, with solar panels spreading about 125 feet across. It seals the samples inside multiple protective layers and starts the long trip back toward Earth. A few days before arrival, the orbiter releases a small entry capsule. That capsule hits Earth's atmosphere, lands in Utah in about 6 minutes, and carries the samples to scientists waiting to study them. Think of this mission as a flying science lab that weighs about as much as a small car and is roughly the size of a compact room. It has 8 large rotors, like a drone, but much bigger, and it can lift itself straight up and land again without a runway. Power comes from a nuclear generator that creates electricity and heat at the same time. That power runs the instruments, charges the batteries needed for flying, and keeps everything warm in a place that is far colder than anywhere on Earth. What makes this project stand out is how it explores its destination. Instead of landing once and staying put, it can fly from one location to another. Titan, Saturn's largest moon, makes this possible. Its air is thick and its gravity is much weaker than Earth's, so flying there takes far less energy. The journey itself is long. After launching in the late 2020s, it will spend years traveling through space before reaching Titan in the mid-2030s. Once it arrives, it is expected to work for a little over 3 Earth years. Most of that time will be spent on the surface collecting data, with flights happening only when it needs to move to a new location. Its tools are focused on learning what Titan is made of and how it works. Instruments study chemicals in the air and on the ground, look at surface elements using radiation measurements, track weather conditions, and even listen for vibrations beneath the surface. Cameras take wide landscape images and close-up views, while small drills collect samples for analysis.